This video is part of the Public Health to Data Science rebrand program.
Hi everyone, it's Monica, the health data scientist here, and today we are going to talk about ETL pipelines. Here are the topics I'm going to cover in this video. First, if you clicked on this video and you didn't know what an ETL pipeline is, never fear. The first thing I will explain is what an ETL pipeline actually is. Next, I'm going to explain why you want to document your ETL pipeline. I'm going to focus on why you would do this when you are working on a research project, but I will also give a shout out as to why you might do it in other circumstances. Actually, the best reason I can give you to document your ETL pipeline is communicated by the image on the slide, which is a picture of two people being very friendly with each other. If you want to make friends and not enemies in the research field, please take me seriously. Document your ETL pipeline. Third, I'm going to explain exactly how to document your ETL pipeline. There are different ways, but I'll show you my style. I'll explain the different files you can make to document your ETL pipeline and walk you through an example based on some real work I did at the U.S. Army. Finally, if you are a SAS user, there is a bonus for you at the end of the video, so please keep watching. Okay, let's move on to answering the question, what is an ETL pipeline? Let's start by considering what the E and the T and the L in the abbreviation ETL actually mean, specifically in the context of a research study. Let's start with the E, which stands for extract or extract. Extract refers to the original data you received from the data provider, or original extract. So if you are on a research team analyzing clinical trial data, the extract would be the raw data you took out from the data system that holds your live study data from your clinical trial. As you know, if you are in this business of data analysis, when you extract data from a data system, it has a lot of problems with it from the standpoint of a research analyst. First, the original extract likely has confidential identifiers or other private data in it that you need for your analysis, like to link study visit data together, but you do not want to share that private data with the entire research team. Also, your extract might have native field names you do not like. When I get data from a SQL database, those field names are often very long with many underscores. I do not want to type all of that when I'm analyzing data, so those native field names could be a problem for me too. Another problem you could have with your extract is that there are fields in it that have issues for various reasons, like they have messy or inconsistent coding, or they are easily misinterpreted. They might be fields that you can clean up, so to speak, and then you can share the clean version with others. But you don't want to give them the raw variable because it's a mess and it's easy to mishandle in an analysis. Okay, let's move on from E extract to T, which stands for transform. So transform refers to the process of taking the extract and doing transformation steps with your code to turn it into the analytic dataset, or the dataset on which you will base your research analysis. I say transformation steps because if you do this stuff, you will know that even in relatively simple cases, you often have to do a lot of coding to go from the original variables you got to the analytic variables you actually want. All that coding is called transformation code, and each change you make to go from the native extract to the analytic dataset is called a transformation step. Finally, after E extract and T transform, we have L for load. In the case of a research project where we are using a static analytic dataset, the term load is kind of a funny word to use because we are not really loading our analytic dataset into any data system. Load in our case technically means publishing the analytic dataset to the group of analysts, or basically sharing the analytic dataset with the research team and pointing out that this is the official dataset that will now be used for the research project. If you are on a research team analyzing clinical trial data, you will appreciate why load is so important. If you are writing 3 different papers off of one analytic dataset, you need to make sure all the n's and percents agree across each paper. Basically, you have to keep your story straight because if anyone reads all 3 papers, they will see discrepancies if everyone on the different writing teams was not on the same page with your ETL pipeline. Okay, now that I've explained what an ETL pipeline is, I will delve deeper into why you need to document your ETL pipeline. First, I'll focus on why you want to do it in a research study. Basically, if more than one person doing ETL has access to the raw data extract from the system, the ETL pipeline documentation is a way to keep all those people on the same page as to how the data is supposed to be transformed from the extract to the final published analytic dataset. Usually, in that case, you have official load code that you all maintain, and you keep the ETL pipeline well documented. But let's say you are doing a research study and only one person has access to the raw data. This is not unusual for privacy and confidentiality purposes. How will the research team understand the data you create to analyze if they do not know how it turned into your analytic dataset? Non-analysts on the research team are often involved in data collection, like they remember some of the data they collected and entered. They will be suspicious if they do not recognize the results coming out of your analytic dataset. So ETL pipeline documentation is a way to answer their queries. And even other analysts may have experience with the dataset, and they will want to know how you went from the original variables you received to the ones you are publishing to share with them in the analytic dataset. Now, this video is not focused on documenting ETL pipelines as part of running a data system. However, I did want to mention that if you want to automate a data system, you really need to get good at ETL pipeline documentation. If you are running a data warehouse and regularly load data into it, you have to do a good job of documenting your ETL pipeline. But even in a small research study, documenting your ETL pipeline is just a part of good data stewardship and governance. So you really should learn the skills of documenting your ETL pipeline, and you should always try to do a good job of it on every project where you have an ETL pipeline. Now, I'm going to show you how to document your ETL pipeline. First, we are going to go over the minimum documentation you should develop, which consists of 2 things in my opinion, as you can see on the left side of the slide. The first thing you need to create is a complete data dictionary. And when I say complete, I mean that you need to make available all Crosswalk and Picklists documentation, as well as documentation of all the fields in both the extract and analytic datasets. If you are not sure what Crosswalk and Picklists documentation is, or you basically just didn't understand what I just said, don't worry. I'll show you an example. And then the second file you should provide in your minimal documentation is the actual analytic dataset. But that's kind of a gimme because you would be sharing that anyway with the team. Before we get into the additional ETL pipeline documentation you can do, which is on the right side of the slide, let's just go over examples of these 2 items. Let's start by looking at my computer and seeing how I organize my directories for this project. Okay, you will see I have 3 folders here. The first one is called Analytic. That is my analytic environment. I describe in my book, Mastering SAS Programming for Data Warehousing, how and why I set up this environment, but I'll explain it quickly now. You will see there are 3 subfolders, Code, Data, and Doco, which stands for documentation. Let's see what's in the Code folder. Wow, look at that! It's our transformation code. Notice the naming conventions. The first one is named 100, followed by an underscore, followed by a label that gives a hint as to what the code does, which is read in and convert to RDS. By naming it using numbers first, I can adjust the numbers so that I can deliberately line the code up in the order it should be run. That way, I can keep my transformation steps in order. Notice I keep some space between the code numbers, like 105, 110, and 115. That way, if I screw up and need to sneak in another transformation step between code 105 and 110, I can name it with a leading 107 or 108 to keep it in the right order of operation. But also, putting a little label after the number in the name helps. It helps whoever is using the code to keep track of what it is doing. Okay, now let's click on the data folder and see what's in it. Look at all these data sets. The data folder in the analytic environment is a special folder. If you are a SAS user, this would be considered both the in-file and the output folder for data transformation steps. This is the folder where we would put our original extract. It is also the folder where we would save any incremental data sets we made while executing the transformation steps. Also, if we wanted to patch any data on from external sources, like if we wanted to decode some diagnostic codes using an external table with code classifiers and descriptors, the raw external table needs to be in this folder so it can be imported for processing. And finally, this would be the folder where the final analytic dataset would land after processing. The basic rule for the data folder in the analytic environment is that you should theoretically be able to erase all the data in the folder and not lose any original copies of data. In other words, this data folder just holds copies of original data, like a copy of your extract, a copy of your external diagnostic code table, and a copy of your analytic dataset. Of course, datasets written to this folder during transformation steps can be regenerated by just running the code. But you have to make sure you store the official copy of the other datasets somewhere else for safekeeping. Okay, now let's click on the DOCO folder and see what's in there. Well, it looks like we have two files in our documentation folder. The first is a data dictionary in Excel, and the second looks like a diagram in PowerPoint. We will look at these momentarily, but let's look at these other folders that are outside the analytic environment first. Okay, it looks like we have two different folders to look at outside the analytic environment. Let's look in the folder called Crosswalks. Okay, we see three Crosswalk files in there. The first is called Age Group Crosswalk, the next is MOS Group Crosswalk, and the final one is called SSN DEID Crosswalk. So these are examples of external tables you can use in transformation steps to help decode original variables you get, like the diagnostic code example I gave. The original Crosswalk files are here. Okay, now let's look in the last folder, called Original and Final Datasets. Okay, it looks like we have three datasets here. The first one, labeled 1, is the original dataset from the provider. Of course, this is just fake data I made up. But I wanted to make it realistic. Actually, let's open this file up and look at it. This is our E for extract. Wow, this is a very small data set. It only has 10 rows. That's because I was lazy and just wanted to make up a small data set for demonstration. In real life, this could have thousands or millions of rows. But notice it also only has 3 columns. But yet, you'll see that to get to the final analytic data set, we do multiple transformation steps. That's not unusual. Let's look at these 3 fields we got from the data provider. See this variable called SSN? That stands for Social Security Number, which is a private identifier used in the United States for each individual. How you can easily tell these are fake data is that my SSNs here only have 6 digits, and real SSNs are 9 digits. But the reality was that when I worked at the Army, we would use private identifiers like SSN to link records. And we didn't want to share data with SSNs in it, but we wanted people to be able to link records across datasets. I will show you how we solved that problem through our transformation steps. Here is our next column, date of birth, abbreviated DOB. This is another very private piece of information that no one analyzing these data really needs to know. However, you can see a use for us knowing what age each individual is, and since we have a date of birth, we could calculate age at any known date. So we definitely could make an age variable to give out to analysts. That's not very private. We just have to choose a date from which to subtract the DOB to calculate age. But if you just think about having age as a variable, what's the first thing we always do with a variable like age? Well, we put it into groups. But before I can get that far, I'm going to have to convert this field. Right now, it is a character field with sort of a date format, but not an official date field. See this first record? The date of birth of that person is in the year 2001, followed by the month of February, followed by the day of 14. I wonder whose birthday is on Valentine's Day in real life. In this fake data, it is military member 123456. And in order to figure out this member's age and age group, we will have to do a lot of processing on this native DOB field, which is a date stored as a character string. The last of these three fields we got from the data provider is named MOS. I use this particular field deliberately to illustrate an example I ran into at the Army. I also have run into this problem in other big data contexts, where a system has data over a long period of time. First, let me explain that these MOS codes refer to the occupations of service members in the Army. As you can see, the first three individuals have the MOS code of 11B. The way this works is that I know that the 11 means that they are part of infantry. But the B part, the letter after the code, that's where the debate starts. Let me give you more backstory. See this web page that says ASVAB? This is the test people take in the Army so the Army can decide what occupational class to train them in. The classes have what are called MOS codes. See, here is a succinct list. Remember how I just said that 11B meant 11, so that meant infantry? We can see here there are a lot of these MOS classifications. Some are ones you'd think of with an army, like 13 for artillery and 25 for signals communication. But there are others you might not think of, like 27 for legal services and, one of my personal favorites, 68 for medical. These are really enduring classifications. If someone was in the U.S. Army during World War II and they were a medic, they would have had an MOS classification of 68. Pretty crazy, huh? Now let's get into what's wrong with the letter after the MOS code. Let's look at these subclassifications for the artillery class, which is 13. We see 13B is a cannon crew member. Maybe this has been around since World War II because we definitely had cannons then. But then let's look at 13P, Multiple Launch Rocket System Automated Tactical Data Systems Specialist. Okay, I assure you there were no Multiple Rocket System Automated Tactical Data Systems Specialists working during World War II. But here's the kicker. That does not necessarily mean that there were no occurrences of the code 13P in the data from World War II service members. And why is that? Well, over the years, they recycled the codes. And they did not keep track of which years they recycled what codes. So let's say that during World War II, they had some old-fashioned job class based on old technology. As an example, with communication back then, they had telegraph operators in the Army that you would not have today. So for certain years, 13P probably meant something pretty old-fashioned, like something to do with cannons or other old technology, as we saw with 13B. But then when we started getting into multiple rocket launch systems and needed tactical data systems specialists, we needed a code to assign to that new job class. So 13P could have meant something to do with cannons or other old technology during World War II, but then when we retired that technology and started using this new technology, we needed a code. So 13P gets reassigned. For that reason, I did not want to serve up the full MOS code to anyone because the codes with the letters on them were so unstable. I just wanted to provide everyone with the MOS classification and a way to decode it, like that list I was showing you online. All right, now that you were able to take a peek at my example extract with all the private data in it, let's turn to one of the minimally necessary curation files, the data dictionary. Okay, let's get our bearings in this data dictionary before I explain it to you. We have 3 tabs in this data dictionary. The first one I called main. This is the main tab to document fields. The other 2 tabs, age group for age group and MOS group for MOS group, are documented picklists, which I'll show you shortly. Now let's focus on what the columns are in the main part of the data dictionary. Let's start with this order column. The purpose of this column is to use it in sorting. I'll give you an example. See these 2 fields, SSN followed by DEID? Right now, these are on rows 5 and 6 of the data dictionary. Imagine I wanted to add another ID to the dataset, and I wanted the ID to fall in the dataset between SSN and DEID. I'll show you how I would use the order column. Let's pretend this new ID is called military ID. I'll pretend to document it on the last row of the data dictionary. Now, remember how I wanted it between rows 5 and 6? Well, I can make the order value be 5.5. Then I can select the entire data sheet and sort it by order, and the field will come into the right place. But I'm not going to do this just now. I just wanted to show you this. Let's cancel out of this and erase that military ID field. Next, we have an original field name column. At the Army, we liked those native field names because they were short and easy to use in programming. But sometimes when you receive data, you do not like the original field names. If that is the case, you can easily mass rename all the native fields in a transformation step. What you would do is make an extra column in your data dictionary where you would indicate the new field name you want to use for that variable. But we are not going to do that, so let's undo out of this. By the way, how do you feel about the native field names you get in data? Do you like to mass rename them? And if you do, what kind of naming conventions do you use? Go ahead and share your experience in the comments. Next, we have the description column. You know what that is. It describes the data element, like date of birth. But then we come to the source column. This column is really important. I use a code in this column. The word native means that this variable was given to me in the E extract from the data provider. Remember, we only had 3 variables in our source data set. Can you find them labeled in the source column? Good job! It's our old friends SSN, DOB, and MOS that we just talked about. But basically, what that means is that the other variables labeled R are ones that I literally manufactured in R. Look at all of them. I literally added 9 variables based on the 3 I got. So you can see why you need to meticulously keep track of all this. Let's move to the values column. I basically put 2 types of information in the values column, depending upon whether the variable is a code that can be decoded, like MOS classification, or the variables are just a straight up value, like date of birth. Actually, in our case, the first 9 rows are for variables that are just a straight up value. The first variable, row ID, that column is just filled with integers. For the next variable, file name, you can see that I provided an example of a value for file name, which is 2023 Jan, meaning the 2023 January monthly file. This might even be the actual file name of the e-extract. In my SAS Data Warehousing book, I demonstrate how if you rename your extracts strategically and use code arrays and macros, you can automate reading in multiple month and year files at a time, so long as you strategically name the files. In the automation, you can ask SAS to copy in the file name to one of the fields, which is what we did here. The next field, file year, is the year of the file, which would be 2023, and the next variable, file month, includes integers for months, as you can see in the values column. Then on the next row, we document SSN and we show an example SSN, 1, 2, 3, 4, 5, 6, in the values column. So you can see how I just put an example of a value from one of the variables in the values column. But now let's look here at variable 10, which is age group. Notice how the term in the values column is AGEGRP. Basically, it's referring you to the age group pick list, which is documented in the second tab. After that, we have MOS and an example value from the values column, which is 11B. But then for our last variable, MOSGRP, we have the same situation, where the values column refers us to a pick list documented on the third tab. You are probably curious about what is on those tabs. We'll look at those in a moment. Let me first point out this next column, which is called Include in Analytic. This is a really important column if your e-extract has a lot of private data in it. Notice how I put an X in the rows indicating which variables I want to serve up in the analytic file. Do you notice any patterns to how I flagged these fields? First, I want you to notice that I left out these variables because they are private, like SSN, or because they are messy and I don't want you to have the variable. That's MOS code. We can't decode 11B or 13P accurately over time, so why should we let you have that code? That was my thinking. The other fields are there to basically add value to the dataset. I'll explain more when I go over our actual ETL code later. But for now, let's move on to looking at our pick lists, starting with age group. Let's look at how this pick list is documented. We see 4 columns, AGEGRP, which has the value of the age group variable, and a pair of columns labeled low age and high age. If you wonder what those are, they are limits that can be used in programming if we turn this pick list into an actual data set we read into R and use in transformation steps. We can use these variables to classify raw age values into the groups defined under description, as you can see on the right. Now, this is the Army, which is why we have just a few younger age groups. It's a business rule. Actually, let's take a quick peek at the other pick list, MOS group. We'll click on the third tab. Okay, you recognize this list. I just showed it to you on that web page. All right, we got our data dictionary. Let's go back to our slides and see if we are missing anything. Well, let's see. For our minimum necessary list, I just showed you a complete data dictionary with pick lists documented. And I showed you the original Crosswalk files in the Crosswalk folder. You would not give out the SSN to DEID Crosswalk because the SSNs are private. But you could give out the other crosswalks and pick lists so long as they didn't have private information in them. So that's number 1 of the 2 minimum necessary files to document your ETL pipeline. What's the second one? It's your actual analytic dataset. Let's look at ours. Remember our folder titled Original and Final Datasets? That's where we will click to look for our analytic dataset. See the dataset labeled 2 Final Analytic Dataset? We'll open this one. All right, here it is. Are you surprised by these variables? No, you should not be surprised at all. You should have expected all of these variables. Why? Because we just went over each one in the data dictionary. You know what DEID is. it's a de-identification variable, so I don't have to use SSN. And you know what MOS group is and why MOS is not there. So imagine you were a person receiving this analytic data set so you could analyze it. If you were already familiar with SSN and how it is used to link files, you'd be looking for a linkage variable in your analytic data set. And if you are familiar with MOS, you'd be looking for MOS in your analytic data set. Can you see how simply giving someone analyzing the data a complete data dictionary and the analytic data set can really save a lot of communication trouble? Like, if the data receiver said they needed a linkage variable, I'd point them to the DEID variable. Or if they ask why I just gave them the MOS grouping and not the code, I tell them why. So this is very helpful for communication. In fact, when I make HIPAA data use agreements, I usually include data dictionaries like this in our agreements as an attachment, just to make sure we know exactly what data fields we are talking about in our agreement. Okay, now I'm going to get to the additional documentation you can do, which is on the right side of the slide. I put the documentation in the order of most helpful to least helpful, but trust me, all these have at least some amount of helpfulness. Let's start with the first item, well-organized ETL code. Let's take a look at our code folder. Okay, this looks like well-organized code, doesn't it? Let's open one of these. We'll just be lazy and open it in Notepad. Let's open code 105, which is labeled de-identify. So don't feel bad if you don't know R and can't read this code. I'll tell you what it says, and you can probably follow along. First, we import a dataset in RDS format called month_A. Next, we import our SSN to DEID crosswalk. Then, we merge the two datasets joining on SSN. Finally, we drop the SSN. So basically, we replace the SSN with the DEID, and then we export an RDS data file called month_C. So this is an example where the data receiver could receive this code file, but not receive the actual SSN field or the SSN to DEID crosswalk. But this code file could convince a skeptical data receiver that they actually are getting a real linkage variable based on SSN. So this is why it can be helpful to provide your well-organized load code to the data receiver so they totally get what you did to manufacture the dataset. Okay, that code was nice, but let's admit it, it was pretty hard to pick through that code and figure out what it did. And let's say this is a real big project. Sometimes there are a zillion code files. So you might be thinking, do I really need to pick through all that code? Is all that code really helpful? Well, the answer to that is yes, the code is helpful, but you can make that code even more helpful if you include item 2 on the right side of the slide, which is an ETL pipeline diagram. Let me show you that. You might remember this file, this PowerPoint file called pipeline diagram. This was the only other file in the doco folder, along with the data dictionary. Let's just stare at this diagram for a moment. Can you identify the transformation step we just looked at in the code, where we patch on the SSN to DEID crosswalk to de-identify the data and remove the SSN? Well, there you go. See that? You zoomed right in on the transformation steps happening in code number 105. Remember, we just looked at code 105, where we imported the private SSN to DEID crosswalk and then merged it with the main dataset and outputted it, keeping the new identifier and dropping the SSN. So you can see how if you were a data receiver and you receive the code and also this nifty diagram, you would basically have a map you could look at before you decided to actually open a code file and look at the code. All right, so over on the right side of the slide, I showed you item 1, well-organized ETL code, and item 2, the ETL pipeline diagram. You might think, zoinks, that's already an awful lot of curation files. Do we really need any more? Well, once in a while, I get really confused about data. I am remembering a few times in my life where I got data from a provider with identifiers and linkage variables that I really did not understand. In that case, the data provider gave me the last item on the list, number 3, which is an example of de-identified source data. Let's look at this. Okay, here we are in our File Explorer. Let's click on the folder Original and Final Datasets. See the file labeled 3 de-identified sample of data? Let's open it and look at it. Okay, remember much earlier in this video where I showed you the E extract that only had 3 variables? Well, this is essentially the same thing, only it is deliberately faked. There are only 5 records. It's not unusual to receive just a few records. Let's look at what is in each field. You'll notice the SSN is obviously faked, but it is in the 6-digit format. That communicates to me that the raw SSNs look like this, 6 digits. Now, if I'm the data receiver, I will definitely notice this when I get the data. But if I'm just negotiating a data use agreement and I don't have the data yet, this little fake extract can tell me a lot. Next, we can look at DOB. These are obviously fake DOBs. Each person is born on January 1st, but in different years, 1999, 2000, 2001, and so on. If I get this fabricated data before I get the real data, like after our agreement is signed and before they have time to get me the extract, then I can use this fake DOB field to prepare how I will process the data. Remember, this is a date stored as a character, and there's going to be a lot of programming work done on that. So it is helpful to have this fake data that is realistic, so I can begin to create my load code. And as you can see, we include some MOS codes to show an example of what is in that field. Okay, here we are. Now you should completely understand everything on this slide. You should know how to prepare a complete data dictionary and give it to your data receiver, along with the analytic dataset, to help them understand how you transform the native data into the analytic dataset. You can do this efficiently without sharing private data. Hot tip! If you are doing a dissertation project, use the data dictionary to communicate with your committee and your advisors about how you transform the analytic dataset for your project. And if there is more confusion among your research group or between you and a data provider or receiver, just make the other additional documentation. You may not be able to share data, but you can usually share your ETL code. And you can always share an ETL pipeline diagram so long as you don't put any private information on it. And you can always make a sample of fake data to communicate what the real native data look like. Okay, SAS users, did you hang in with me until now? Wonderful. Here is your bonus. Here is your special SAS surprise. SAS users, do you feel overwhelmed? The reason I ask is that I find it really challenging to program in SAS, so I get really exhausted. And if you are like me and are already exhausted from programming code in SAS, you are probably doubly exhausted by looking at all this curation documentation. But your reward, SAS user, for doing all this curation documentation is that you can actually implement it. If you carefully curate all these steps, you can automate your ETL code in SAS Data Integration Studio, known as DI Studio for those of us in the know. My point is that if you learn about SAS DI Studio, you'll realize that an ETL pipeline diagram, organized code, and most of the other curation files I mentioned in this video absolutely need to be in order before you even approach using DI Studio. All right, here's the bonus part. Please follow my instructions and go to the link on the slide, which I also put in the description. It is a link to a SAS support page with some tutorials. Then scroll down to the section that says Videos and Tutorials, and I want you to watch 2 videos. The first one I want you to watch is called Creating a New Job, and the second one is called Populating a Simple Job. They are really short, like less than 5 minutes. Hey, if any of you out there watching this are working at a place that actually automates its jobs using SAS DI Studio, please make a comment and tell us about what it's doing. I'm explaining using DI Studio for an ETL pipeline, but it can obviously be used for other types of pipelines as well. Okay, I'm so excited about these 2 DI Studio videos, I can't leave it alone. I have to summarize what is in those videos. In the first video, the Creating a New Job video, they basically tell you that each time you build an ETL pipeline in DI Studio, it's called a job. So basically you create a job and save it, and that is your ETL pipeline that you can keep working on until it's perfect. So in this Creating a New Job video, the instructor shows a screen with a bunch of menus on the left, as I diagrammed here. Then the instructor drags a data set from one of the menus out to the main screen. This indicates the original data set at the start of the pipeline, basically the E extract. And then you save the job, meaning you save the pipeline so you can come back to DI Studio and work on it later. Next, we move to the Populating a Simple Job video, which picks up where we left off after the last video. In this video, the same instructor already has the saved job open. What he's doing in this transformation step is just sorting the data by some variable and then exporting it in the sorted format. So he basically just has one transformation in this step, and how he sets that up is he drags a sort function from the menus out to the main screen. If you actually watch the video, the instructor shows you how to make that connector arrow between the dataset and the sort function. He will show you how you can configure that arrow to do things a certain way, which is really cool. Then after that, the instructor goes back to the menus and drags out the final dataset that will be exported. I called it B in the diagram. Again, he demonstrates connecting the sort function to the final dataset and how you can configure that connection. So the take-home message is that whether you are a SAS user or not, ETL pipeline documentation is eminently useful. If you are a researcher, even a graduate student, it can help you communicate with your colleagues, supervisors, and professors. And if you are building a data warehouse, in the end, if you do a good job with your ETL documentation, you can even build a job in DI Studio. But the most important point I want you to learn from this video is that creating and sharing comprehensive data documentation is good governance. It's an example of excellent data stewardship, and it's the right way to communicate clearly about data without actually sharing the data. Thanks for joining me, Monica Wahi, healthcare data scientist, for another adventure in data curation. I hope you had as much fun as I did. Bye-bye. See you soon.
Thank you for watching this video, which is part of the Public Health to Data Science Rebrand program. If you are interested in joining the program, please sign up for a 30-minute Zoom interview using the link in the description.